Good morning, chemistry fans. Here we go again, another gas law lab, joined again by my trusty and faithful lab assistant, who's very close, aren't we? All right, fine. Be that way. Goggles off. Anyhow, this lab, we better fix you for safety. In this lab, what we're going to look at is what happens if you rapidly change. This kind of is more of a combined gas law lab as to we have an initial pressure and temperature safety first. We have an initial pressure, temperature, and volume. What I have here, as you can see, that I stole from my wife because I don't drink sparkly carbon dioxide junk, but it's a little Michael Bublé water or whatever they call this bubbly stuff. And I'm not telling her, but I brought it to school and poured it out. So I have this can. Now the can itself says it is 355 milliliters, but that is a lie. They're always lying too. Well, the can is the volume is what's inside the can. The can itself is 370 milliliters. I measured it, I filled it up and measured it out. So I have a can of 370 milliliters. What I did then was, after I checked the volume, I put in 25 milliliters of water. And what we're going to do, let me tilt this down, is we're going to put this on the hot plate and let it start heating up. Okay. And I'll do that right now. What I want to do is turn my water into gas vapor. Most of it kind of staying in the can. It won't be perfect. Certainly it's exposed to the atmosphere and some will come out. And then what I also have, which I'll show you here, is I have a big old bucket of ice water. More ice than water right now. And so what's going to happen here as we do stuff, and I'll put this up again. What's going to happen here is I'm going to heat this, and I'm going right to that point where the water is basically all converted to steam, to gas form. And then I have this beaker tongs here, and I'm going to rapidly take the can, invert it rapidly, and plunge it underwater upside down so that the can opening then goes underwater and essentially seals the gas in there. And by plunging it in, I am drastically changing the temperature that the gas is under, basically from boiling from about 100 degrees to zero. And so the effect is what's going to happen, that's going to drastically change the pressure on the gas, the pressure and the volume, because as temperature goes down, pressure goes down, as certainly, and so does the volume of the gas. So that is going to rapidly shrink in there as the temperature drops. And of course, by being sealed, then you have we're at 101 kilopascals right now out here at about 19 degrees. The room's about 19 degrees. We're about 101 kilopascals, which is, doesn't matter what the room is, but you're going from about 100 degrees at 101 kilopascals, and now you're going to 0 degrees. And we'll see what the volume of the can is after we get there. I can hear it starting to bubble up. And we'll see that because it's sealed and the pressure inside drops dramatically, and the pressure outside, it should crush the can. Anyhow, this is going to take a little bit. So what I'm going to do is I'm going to pause the recording for now, and then we'll come back. Okay, we're back. Me and my trusty assistant. I think we're getting very close to decision time. So I'm going to bring the bucket of water right over here. I switch things around because I'm right-handed. And so what I'm going to do is grab this, and again, rapid, quick, deep plunge. We'll see how well I do. I haven't done this in a few years, and hopefully I've judged it right to where there's almost no water left, and you'll see the quick crush of the volume. And I did horrible. And I tell you why I did horrible. I can tell you why I did horrible is I ran it. This is just terrible. You couldn't hear it, but I have too much ice. I couldn't plunge under. So stay tuned. We're going to do it again. And I'm going to have less ice. I couldn't get it under. I think I was spot on because there was really no water left, but I couldn't get under the water. Anyhow, so we will try again tomorrow. Move this out of the way. We will try again tomorrow when we're doing another gas absolute zero lab demonstration for you. But either way, no bones about it. Chemistry is fun, and we'll see if we get a better job done tomorrow. Talk to you later.